Have you ever looked up at the night sky and wondered where it all came from? For decades, the story has been the Big Bang, a single, infinitely dense point that exploded, creating everything we see. But what if that story, as grand as it is only part of the picture? What if our universe had no beginning at all? This idea might sound like science fiction, but it's a concept that some of the world's leading physicists are seriously exploring. The standard Big Bang model is incredibly successful, explaining so much about our cosmos. But it has a major blind spot, the singularity itself. The laws of physics, as we know them, break down at that initial moment. It's like trying to divide by zero. It just doesn't compute. This has led scientists to ask a revolutionary question. What if the Big Bang wasn't a beginning, but a transition? A moment of change in an eternal, cyclical cosmos. One of the most fascinating ideas exploring this is called the Big Bounce. Imagine our universe like a giant lung. It expands just as it is now for trillions of years. Gravity slowly pulls everything back together, not into an infinitely dense point, but into an incredibly compact state. Then, instead of collapsing into nothingness, it bounces. A new expansion begins, creating a fresh universe from the ashes of the old one. In this model, our Big Bang was just the latest bounce in an infinite series of expansions and contractions. The universe has no beginning and no end, just an endless cosmic rhythm. This concept elegantly sidesteps the problem of the singularity. There is no moment where physics breaks down, because the universe never truly crushes itself into a single point. It's a continuous, self-renewing cycle. But there are other ideas, too, that stretch our minds even further. String theory, a candidate for the theory of everything, paints a picture of a universe with more dimensions than the three of space and one of time that we experience. In this higher dimensional reality, our universe might exist as a brane, short for membrane, floating in a larger space called the bulk. Think of it like a single sheet of paper in a vast, multi-dimensional library. According to what's known as the ikpyrotic model, our Big Bang could have been caused by the collision of our brane with another. These two cosmic membranes, drifting through this higher dimensional space, finally smacked into each other. The colossal energy released in that collision would be powerful enough to heat our universe and trigger the expansion we call the Big Bang. This brane collision theory is profound because it also suggests our universe could have an infinite past. Before the collision, our brane universe existed, perhaps in a cold, empty state. The collision wasn't a creation from nothing, but a dramatic reheating event. It was the spark that reignited a pre-existing cosmos. And just like the Big Bounce, this could be a cyclical process. Branes could collide, separate, cool down, and then collide again, setting off Big Bangs over and over across eternity. Each collision would wipe the slate clean, initiating a new cycle of cosmic evolution, with new stars, new galaxies, and perhaps even new laws of physics. This changes our entire perception of time. We're used to thinking of time as a straight line, with a clear start and an arrow pointing towards the future. But these theories suggest time might be cyclical, or that our universe's timeline is just one chapter in a much larger, eternal story. Our existence isn't a one-off event, but part of a grand, repeating cosmic drama. So how can we possibly test these mind-bending ideas? It's not easy, but scientists are looking for clues. One place is the cosmic microwave background, or CMB. This is the faint afterglow of the Big Bang, a snapshot of the universe when it was just 380,000 years old. If the universe is cyclical, there might be subtle patterns, or anomalies, imprinted on the CMB from the previous cosmic era. For example, a Big Bounce might leave a different kind of gravitational wave signature than the standard Big Bang model predicts. Detecting these faint ripples in spacetime could be the smoking gun that tells us whether our universe bounced or banged into existence. Similarly, the brane collision model also makes specific predictions. The collision wouldn't be perfectly uniform, across the entire brane. It would create temperature variations in the early universe that might still be visible in the CMB today. Scientists are combing through data from powerful telescopes like the Planck satellite, searching for these telltale signs. It's like cosmic archaeology, sifting through the oldest light in the universe for evidence of what came before. Another exciting frontier is gravitational wave astronomy. Observatories like LIGO and Virgo have already opened a new window to the cosmos by detecting ripples in spacetime from colliding black holes. Future, more sensitive detectors might be able to pick up the primordial gravitational waves from the very first moments of our universe. The specific sound of these waves could reveal the true nature of the Big Bang. Was it a singular event? Or was it a bounce or a collision? Each scenario would produce a unique gravitational wave symphony, and we're just now learning how to listen. Thinking about a universe without a beginning can feel overwhelming, but it's also incredibly liberating. It suggests that the cosmos is not a finite, fleeting thing, but something eternal and endlessly creative. It forces us to reconsider our place in the grand scheme of things. We're not just inhabitants of one universe, but potentially one iteration in an infinite cycle of cosmic birth, death, and rebirth. The story of our origins is far from settled. We are living in a golden age of cosmology, where new evidence and bold theories are constantly challenging what we thought we knew. The Big Bang might not be the beginning of the story, but merely the start of our current chapter. And the quest to understand what came before is one of the most exciting adventures in all of science. Thank you so much for joining me on this journey beyond the Big Bang. If you're as fascinated by these cosmic mysteries as I am, make sure to hit that subscribe button and ring the bell so you don't miss our next exploration into the unknown. What do you think came before the Big Bang? Let me know your thoughts in the comments below. Until next time, keep looking up.